This discussion is on polynomials factoring using monomials. Okay, let's begin with a definition of factoring. What is factoring? Well, factoring is finding numbers and variables that are common in two or more terms. Okay? Let's see. Let me give you an example. 16 and 12. What are some common numbers in 16 and 12? Well, the way to figure that out is to get its primes, to break this down to primes. Let's see, 16. What makes up 16? Well, 4 times 4 makes 16. Well, can 4 and 4 even break down further? Yes, it can. To 2 times 2 times 2 times 2. Now, these 2's are all prime. So, 4 2's make 16. Okay, so here's what we're looking for. Now let's break this 12 down. Let's see, 3 and 4 make 12. Well, 3's prime, yes, but 4's not. What makes up 4? 2 times 2. Now what we want to do is we want to look to find common numbers in both groups. A group of 2's here and a group of 3 and 2 2's. So now we go in and what we do, we circle anything that is common in both groups. Look here. A 2 here, oh, and a 2 here. There's another 2 right here, and another 2 right there. Now, there's 2 more 2's here, but no more 2's available over here, nor is there's a 3 here, but not a 3 here. So, what's common are these 2 2's. And then we multiply those 2 2's times 2. We find that 4. 4 is the common number in 16 and 12. And that is the process that we go through to find common numbers or variables in terms. Let's try another example. I'm going to erase this one. Oh, my big eraser. And let's try this here. Let's see here. 5xy and 2xz. All right. Let's rewrite this, and really, here's what I'm going to do. I'm going to say that I'm just going to show it in a different way. 5 times x times y, and I want to show this as 2 times x times z. Okay, what is common in this group and in this group here? There's a 5 here, but not a 5 here. There's a 2 here, but no 2's there. There's an x here. There's also an x here. Let's circle that. Y and a z. Okay, the only thing that's common is x. So, we say that x is our common number or variable in these two terms. Okay, so that's enough discussion on how to find a common number or variable between two terms. Now, let's actually go to, you know what, let's try a different one, a little larger one maybe. Let me erase this real quick, my big eraser. And let's try these. 30xy squared and 3x squared z. Alright, let's start with 30. 30 is not prime. What makes up 30? Let's see here. 15 and 2. 15 times 2. Okay, 15 is not prime. What makes up 15? Well, 3 and 5. And then 2 is prime, so we'll go ahead and multiply that. Now, let's bring our variables down. We're going to bring them down, and we're going to list them the number of times they have an exponent. So x has an exponent of 1, so we're going to say x. Y has an exponent of 2, so we're going to show y twice, just like that. Now let's go over here. 3 is already prime, so we can just bring that down. X has an exponent of 2, so we list x twice. And then z has an exponent of 1, and we'll list it one time. Now, let's look at these and see if we can find common numbers. Let's see, is there a 3 in both groups? Yes, there are, right there. So let's circle that. Okay, 5. 5's not in both groups. What about 2? Nope, there's no 2 over here or 5. X, yes, there is an X. Let's circle the X. Okay. Y's. Two Y's here, but no Y's here. And so we have done. We don't have, the only thing we have common is 3 and an X. If that is the case, we would say that 3 and X are our common numbers, or common number and variable, or a common term, if you will, in both of these terms. Now, we've done enough examples. Let's actually factor an expression. Let's factor it. All right. Here's an expression, 8x 6 minus 20x to the fifth. Okay, so now here's what we're going to do. We're going to list all of the prime numbers and variables of the 8x to the sixth. And here's what they would look like. 8, I know that 2 times 2 times 2 make up 8. Now let's list x 6 times. 1, 2, 3, 4, 5, and one more time. All right. Now we've done 8x to the sixth power is listed right here. Now let's do this negative 20x to the fifth power. Now it's negative 20, so let's first of all put a negative 1 out there to represent the negative. And then what makes up 20? 4 and 5. Well, 4 is not prime, so let's list it 2 times 2. That makes 4 times 5 makes 20. And then x 5 times. 2, 3, 4, 5. Now, let's go through and find out what's common in both groups. Let's see here. We have a 2 here, and we have a 2 here. We have another 2 here. We also have a matching 2 over here. There's no more 2's. There's 2 here, but no 2 here. But there's some x's. See, 1. Now notice, we can circle as many as we have in both groups and no more. 3, 4, and 5. Okay. So now, what is our common number? Common number would be 2 times 2 is 4. And how many x's? 1, 2, 3, 4, 5 x's. 4x to the fifth. Okay. Now let's make a parenthesis like this. And then let's go back and pull out what is not circled. You have 2x is not circled, so that would go here, representing what's left of the 8x to the sixth power. And then let's go to see what's left here. The only thing not circled is negative 1 and 5. So negative 1 times 5 would be a negative 5. And that represents what's left of the negative 20x to the fifth. Okay. Now, that is what we've done. We've factored out 4x to the fifth out of these two terms, leaving us with 2x minus 5. Now, that would be our solution if we were asking for you to factor these two terms. The question is, how would you check that? Quite simply, you have already multiplied a monomial by a binomial, and that's what you would do to check it here. Let's go ahead and check and make sure that it works out. 4x fifth times 2x. 4 times 2 is 8. X to the fifth and x to the 1 gives you x to the sixth. 4 times a negative 5 is negative 20. X to the fifth. Let's just put that down there. Now let's compare this to our original. 8x to the sixth, 8x to the sixth, minus 20x to the fifth, 20x to the fifth. They're exactly the same. So we have done a correct job. So it checks out. Okay, let's try a little bigger problem. Let's scroll up here. Okay. Okay, let's try this one. 4xy minus 2x squared y plus 8x squared y squared. Okay, step number 1. Let's break it down to its primes. Well, I know 4 can be made by 2 times 2 times x times y. Okay, this one I have to do a negative 1 because it's negative times 2. Now it gives me a negative 2 times x times y. And then this one is 2 times 2 times 2 times x times y times y. Now this makes 2 times 2 xy makes that. Negative 1 times 2 times xxy makes this. And 2 times 2 times 2 xxyy makes this one here. Now let's go through and see if we can find what is common. Okay, common is 2, 2, 2 is in all three groups. There is an x here, and an x here. See, there is an x here, but no x's here. So let's see, is there a y in every group? Yes, there's a y in every group. So let's do the y's now. Okay. Now, we only circle what is in all three groups. That's what factoring is about. Okay, so there's nothing else. So now let's write what is common. Every one of them has a 2x and y. So we say 2x, y, and then what goes in parentheses? We're going to put three terms, and what those three terms will be is what's left over of each of these. So I have 2 in the first one, so that's 2, and then negative 1 and x would be a negative 1x, or just negative x, and the last one, 2 times x times y, so you have plus 4x, y. And there's my final example. Let me make this look a little bit better. X, y, parentheses, 2 minus 1x plus 4x, y. Alright, now notice what we have. We started with three terms. We factored out a 2xy out of all three, and we're left with our factored term and what is left of the three terms. 2, negative 1x, and 4xy. And that gives us our final answer. Now, if you want to check to make sure this answer is correct, then multiply this 2xy, multiply this right here by everything in the parentheses, and you should end up with our original problem up here. Alright, that concludes our discussion. And now